In this lesson, we're going to be learning about the regression line, and we're going to learn how to find the equation for this regression line. A regression line is a line that's on a scatter plot. When you have your scatter plot and you draw a line of best fit, your line that tries to touch all the points, that's a line that best represents all the points on your scatter plot, and that's our regression line. So it's a line that best represents the relationship between the two variables. So if their correlation is positive, the slope of your line should be positive, for example. And we use the regression line to make predictions about our statistics. So if you have your list of statistic numbers and you're trying to find one that's not in the list, well, you can use the equation of the regression line to find that. And I'll illustrate with an example. But first, let's look at the steps to finding the regression line. So the steps are listed here. There's 4 steps. And I'm going to illustrate with the following example. So our first step is we have to order the points in the distribution according to the x coordinates. And that's very important. It's according to the x coordinates. So if we take a look at our example here below, down here, so we can see that the points are already ordered according to x. They're already in the correct order. So step 1 is done for us. Then step 2. Divide the points into 2 equal groups, if possible. It's possible that one group might have 1 point more than another. So if we look here, we have 5 points here, and then we have 5 points below. So I've shaded them for you to indicate that this is the first group, and this is the other group. Third step, we're going to determine the mean of the x coordinates, that's the average of the x coordinates, and the mean of the y coordinates. And that'll give us a point. It gives us a mean point. So first we'll look at the first set of numbers. You're going to find what is P1. P1 represents x1. x1 is the mean of all the x coordinates in the group, and y1 is the mean of all the y coordinates. So I'm going to ask you to try to find that. Start by looking at the x coordinates that are shaded. Find the average or the mean of these numbers, 6 up to 14. And whatever you get for the mean, you're going to put in your ordered pair here for x. And then do the same thing, find the mean for y. Pause the video here, please, and find the mean. Okay, so you should have found the mean for the x values was 10 and the mean for the y values was 36. So we're going to label these x1 and y1. Now I'd like you to find P2. You're doing the same thing now, the mean of x and the mean of y, but for this group. Pause the video here, please, and find those means. You should have found these values for the mean of x is 20 and the mean of y is 62. We're going to label that x2, y2. Now we can go on to our step 4, where we're going to be finding the regression line. The regression line is a point that goes through points P1 and P2. So you're basically finding the equation of the line that goes through these 2 points. So to find the equation of the line, this goes back to chapter 1, but we'll just review it to remind you. We start with the general equation for our straight line, our linear equation. We're going to start by finding A. A is the slope. So we're using this equation, y2 minus y1 over x2 minus x1. Pause the video here, please, and find the slope. So here you can see the work that I've shown to find the slope using our x1, y1, x2, y2, and we should have gotten 2.6. If you did not get 2.6, check your work with what's written here and try to find your mistake. Now that we have the slope, we can go on and find the b, the y-intercept. So we're going to substitute in the slope into our equation. And then to find the b, you're going to pick one of the points from up here and substitute it in for x and y. So I'm going to pick the first point, so my y is 36 and my x is 10. And we're going to solve for b. So we get 36 equals 26 plus b. We subtract 26 from both sides. We get b is equal to 10. So the equation of the line is y is equal to 2.6x plus 10. Now that we have the equation, we can use it to interpret the data in our graph. So I've shown here what the scatter plot of this graph would look like, and this is the line of our regression line. This is our regression line, and this is the equation of our line, and we just found it here. Now I can use this equation to predict values that aren't in my list of data. So for example, I want to know what would be the point, what would be the y value when x is 9. X equals 9 is not in our list up here. So we can try to read it off the graph when x is 9, but the scale isn't appropriate. We're not going to be able to get a good answer. So we're going to use our regression line. So this was the equation we had for the regression line. And I'm going to replace the x with 9 and solve for y. So 2.6 times 9 plus 10. And we do that calculation, we get 33.4. So when x is equal to 9, the y value is 33.4. Now we're going to look at an example where we're going to use the regression line in a more practical application. So in this example, we're talking about the Granby Zoo, who feeds its elephants daily. The chart below shows the weight of the elephants and the weight of the food that they're given every day. Now we have some steps. First step is going to be to find the regression line, but then here's really the gist of the question. How much food would an elephant weighing 1,600, that should say 1,600, kilograms be given? And we're going to use the regression line to calculate the answer. So 1,600 kilograms is not given in our table. If we go back and look at our table, we don't have 1,600 in here. But we can predict what it's going to be for an elephant weighing 1,600 using the regression line. So I would like you to try this problem on your own. I've added a note here. Your numbers aren't going to be working out all perfectly even, pretty numbers because we're dealing with statistics. And in statistics, we often get messy numbers with a lot of decimals. So my suggestion is keep 4 digits after the decimal when you're finding the regression line, and then when you're finding the answer to B. So answer this question, please. Show all your work, answer A and B, and I'm going to check this in the next class.